Good morning. I'm sure everyone's starting to get, this is sticky. Interesting. I'm sure everybody's starting to get antsy for a break. So I'm Southern, but I talk fast and I get excited. So questions are my favorite part. So I'll try to get through this and make sure we have time for questions as well. So Deputy Morehart had mentioned the Lunar Surface Innovation Initiative. I am from the Space Technology Mission Directorate, and that's what I'm going to focus on discussing today. So obviously, we're focused on both exploration and commerce. I think everyone in the room is familiar with NASA's objectives of boots on the moon by 2024, to get to lunar sustainability by 2028, and we could spend a lot of time talking about what our definition of that is. And then, of course, with a Mars forward approach throughout all of this. In parallel, obviously, we are investing in growing the space economy. So the good news here for LSII is instead of the word sustainability, you're going to hear me use the word infrastructure a lot, lunar infrastructure. And when I say that, I really mean kind of those core key technology areas that we all need, right? We're all going to need power. We're all going to need to use in situ resources. We need comm, we need nav. So these are all areas that we can work together in, especially when we look at the next 5 to 10 years and establishing that core infrastructure and then proceeding from there. So you'll hear me talk mostly about those kind of areas. So I call this my What LSII Is Not chart. And what I really mean by that is this is kind of an overall snapshot of the areas that STMD is developing, those kind of core capability areas. We divide those up kind of from a go, land, live, explore thrust. And you'll see LSII focuses mostly, of course, on the live and the explore when we're talking about being on the surface. And of course, it's obvious that we integrate across all of these systems. This is one mission, and you need all of these capabilities. But this is kind of the formal what LSI is and what it is not kind of chart. And so we'll spend the rest of the presentation talking about what it is. So the actual congressional language is there in the blue box. The LSII aims to spur the creation of novel technologies needed for lunar surface exploration and accelerate the technology readiness of those key components and systems. These activities, and this is an important part that you'll see as a theme throughout the discussion, is that this will be implemented through a combination of unique in-house activities as well as competitive programs and public-private partnerships, going back to how we can really leverage that commerce and space economy development. In terms of key roles and responsibilities, I want to make clear LSII is not a program. We have multiple programs within STMD that LSII is leveraging and executing through, but the real goal of LSII is to establish an initiative where we're really ensuring that there is an ambitious, and I always put that word first, cohesive, executable agency strategy for developing and deployment of the technologies required for successful lunar surface exploration. So obviously this is a huge integration effort. It requires us kind of being tied at the hip within our STMD programs as well as across our other agency stakeholders, especially when we're talking these early missions. So working very closely with SMD and HEO throughout this, as well as other government agencies in industry and academia. And in order to do that, we really have to integrate that broad spectrum of stakeholders. And this is key, develop an acquisition strategy which efficiently facilitates robust collaborations and partnerships. That is not lip service. And I'll talk toward the end of this of how we're going to establish that and get to meaningful work very quickly. Obviously, we have to address, plan, and implement based on our budget needs to enable all of this. And then I've already kind of talked about how we work across our agency stakeholders. So this is kind of the motherhood and apple pie, but it's important to understand that this is the genesis of LSII. See if I can get it to flip. Okay, there it goes. Okay, so this is the What LSII Is chart, and Deputy Morehart had kind of mentioned the 6 key areas that define LSII. Obviously, I just want to stop for a moment and reiterate, many of you know this, but I want to talk what the STMD real goal and initiative is of the Mission Directorate. And it is obviously to work very closely with all of our stakeholders, SMD and HEO in particular. So our real job is to develop and perform the demonstrations that allow the primary technology hurdles to be retired. And this is the key part, right? This is the part we could debate a lot for a given capability at a relevant scale. The relevant scale part alone, we could really have a lot of discussion on, and I'm happy to do so, because that's kind of the phase that we're at now, is defining what that means. While there may be additional engineering development required for additional scale up, if if John wants to take that and scale up, or if commercial entities want to scale up, as we'll talk about for our ISRU roadmap, for example, that could be worked, but there should be really no additional energy required for the foundational technology development. So we will accelerate the technology readiness for these systems. This is especially important to enable early technology demonstrations for the early uncrewed commercial missions, for those CLIPS missions that we talked about earlier. There is so much foundational and fundamental data that we need. I think John and Marshall and everyone has kind of made a reference to that this morning. I mean, let's be honest, we all need to know that the water is where we think it is. Can we get to it the way we think we can? Is it composed of what we think it is? We're going to find this out very early, and it will drive a lot of our kind of if-then logic for mission planning and follow-up. So it's important to have those discussions now and kind of have that mindset ready for those if-thens. So for example, take ISRU. If we land where we think the water is and we can get to it and it works great, we're probably going to go back to that landing site repeatedly, correct? We haven't done that before. So what does it mean when we start driving rovers over that regolith time and time again, or we're landing in that same area time and time again? What does that mean for excavation? And that changes science requirements, it changes technology requirements, it changes mission planning. So these are important kind of dialogues to have early on between all of these stakeholders. So let's talk for a minute, a couple of areas I want to focus on. One of those, of course, is ISRU, which is all near and dear to all of us, I believe. So we have kind of, this is extremely top level kind of, I'll use the term loosely, roadmap for a demonstration timeline. And so for ISRU, we break it out basically to three kind of phases that we focus on. Obviously early on is reconnaissance, prospecting and sampling. And next one would be resource acquisition and processing. And then finally, what I'm calling the pilot consumable production. Now you'll notice as we start getting into resource acquisition and processing and pilot consumable timeframes, the language down below gets a little more generic, and there's a reason for that. So let's talk that for a minute. I think John had mentioned that we have kind of what we're calling a leader-follower path for ISRU. The leader is ice mining, and the follower is O2 from regolith. We are working those in parallel. We actually started in FY19 with some of the hardware and capabilities developed under Resource Prospector through KSC and Honeybee Robotics. And from that, we're developing a very early demo that we call Prime 1, which is the Polar Resources Ice Mining Experiment. In parallel to that, we are developing an O2 from regolith ground demo. We haven't really done a ground demo yet. That is what I would call truly high fidelity, using quality simulants in a thermal vac chamber. So we'll be doing that in parallel to the Prime 1 development. And then somewhere at the end of this calendar, at the end of 20, actually, we'll be able to turn over the Prime 1 hardware because we are leveraging a lot of work that has already taken place, and we'll be well underway for the O2 from regolith ground demo. Based on what we find from this early information, as we discussed, that will help to inform 2 to 3 subsystem demos down the road. One of those that this complements, for example, is Viper that was mentioned earlier with STMD, and so we're working closely with them. They're also working with Honeybee. And so that will help to inform what we do for those. And that's why, again, it's so generically termed. I don't want to name a process at this point. I think we can all kind of pick our favorite or speculate, but I think it's probably dangerous at this point to say we're definitely going one way or the other. So to me right now, what I often say is I'm not as worried, I'm eager, but I'm not as worried about the answers as I am about asking the right questions and prioritizing those early on. And so that's what we're focused on at this time. The other thing that we're focused on is not worrying so much, and everyone take a collective gasp when I say this, in all of these cases of very finite, detailed requirements. And what I mean by that is I'm more concerned with understanding what our key capability needs are so that we don't become too prescriptive in how or what process may meet that capability need. I think sometimes we feel a little bit of maybe even false confidence if we get a lot of requirements on paper. It makes us feel like we're further ahead, but the reality is we still have a lot of questions. So I think understanding what capabilities we need, and then when we work with industry and academia, by being capability focused, by having figures of merits that we clearly bound in terms of must-haves and nice-to-haves, I think we make a lot of progress early on, and there might actually be some real novel ways of getting there. So that's what we'll be doing. And then from those subsystem demos in we're just going to say 24 to 26-ish time frame. We'll have a lot more lessons learned. Those will then be incorporated into our design for what we're calling the scalable pilot system for consumable production. Now, again, this is that giving capability at a relevant scale, right? So we're probably talking more along the lines of hundreds of kilograms of production versus metric tons, for example, that will be scaled up. But that's what we're working on from an STMD kind of roadmap and prioritization. Also want to talk for a minute about power. Obviously, everything needs power. We have a lot of discussions on this, and this is another area that is really ripe for working across industry and academia, as well as obviously internally and within government. So the technology development is currently underway. We're investing in fission surface power, adaptable lunar lander solar array systems, and even some more novel lower TRL development like chemical heat integrated power source, as well as a regenerative fuel cell for energy storage. There's not going to be one kind of miracle occurs here power solution. It's going to be a hybrid approach with multiple technologies. We have some additional investments that we're working on, including a phased system level assessment of power architecture. We just awarded a primary fuel cell technology tipping point to demonstrate fuel cell element on an early lander. And then we have a range of technology development efforts too for our surface-to-surface power beaming, as well as advanced rover energy storage and power distribution architectures. So a lot going on in this area as well. In terms of collaborative leveraging, that is an absolute tenet and really a fundamental aspect of LSII. These are just a few examples of, we started very early in FY19, actually implementing where we had some what I'll call just low-hanging fruit that made sense from a lunar surface perspective to move out on. For example, we had already established ISRU or ISRU next step BAAs that were underway, getting a lot of good data. The studies for those, 2 of the studies have just wrapped up and we got some excellent data. I think Blue Origin just came a couple weeks ago and outbriefed us on their results, which were very impressive. We have Centennial Challenges. And that's kind of like NASA's version of X Prize for those that aren't familiar. We have a Space Robotics Challenge with phase 2 underway now. And then we have 2 other challenges that are LSI related that are in formulation, including an ISRU Production Challenge that builds on the success of the 3D Printed Habitat Challenge, which many of you might be familiar with, as well as a Portable Energy Storage Challenge. We also awarded our first NIAC Phase 3. NIACs are our advanced concepts, and I know a lot of times those are quite advanced and far out, but we do have some cases, like with this Phase 3, that there are actually some relatively early capabilities and benefits. That was for Carnegie Mellon, working with Astrobotic for technologies enabling the exploration of lunar pits. We also have an entity, for those that aren't familiar with it, and within NASA called the Center of Excellence for Collaborative Innovation, or COSI, where they have kind of just a suite of crowdsourcing type mechanisms and entities that we all within NASA have access to using. Really have been impressed with the power you can harness through crowdsourcing. In the early days, I was a little bit of a skeptic if you came to really technical, finite problem solving, and I've just absolutely been blown away by the results that we get. It also keeps us a lot safer from, groupthink, which any agency can be guilty of, and we have a lot of fun with it. Many of these are actually done through a credit card purchase, for example. Yet2 is one of the companies we work with that I'm very fond of. They do worldwide technology searches. It helps us to what I'll call calibrate some of our solicitations before we start, sometimes even before we do an RFI. I'll put one of these out, and they just do an amazing job even getting kind of behind firewalls and seeing kind of where the cutting edge really is, where that competitive edge is, so we can gauge that correctly. I always joke and say I want to find that real cutting edge, but not kind of jump the shark in Star Trek land quite yet. So they help us to do that and make sure that we're being honest brokers in how we calibrate there. And then another thing I'm extremely excited about and very passionate about is our SBIR and STTR programs. I'm an active user of those, and we are actually pursuing now additional ways that the SBIR process can be effectively utilized for high-value early surface activities. DoD and NIH have different types of mechanisms, for example, that they use and leverage SBIRs heavily. We do as well, but these are additional mechanisms that in the near term we could even leverage more effectively through our funding. So I wanted to spend a minute to talk about this work that we're doing with applied physics labs. I think we had some folks here from APL today. I see Nellie back there in the audience. So at the June 28th NASA Acquisition Strategy Council, we actually provided an action response to assess engagement of using existing FFRDCs and UARCs for lunar surface activities. In the most recent study that was done with FFRDCs and UARCs, they had noted in particular that there was a lot of room there for additional engagement, and particularly in some of the novel areas, and they listed specifically, I believe, ISRU and some of the manufacturing and construction aspects, so several areas within LSII. So we actually received approval to utilize an existing APL contract that we have in place, and we'll be providing summaries of those findings and recommendations back by the end of this calendar year. We're scheduled to go back in early December. This initial task with APL was first and foremost to really look at a study for what an LSI system integration role would look like. I'll talk a little bit more of what we mean by that, because I know when I say integration, it's one of those words like sustainability. We could really discuss for a long time what that means to each of us, and it's probably as many definitions as people in this room. But the real focus there was to look at how we would use a UARC to be that in-system integrator to ensure delivery of these technologies and integrated systems for ground surface and ground testing, and then to a lunar provider. And so as part of that, we're looking at establishing a lunar surface consortium. And I'll talk on the next slide in more detail about what that means. But the real important part is it's composed of industry, academia, and NASA with expertise in these LSI key capability areas. And then we wanted to go ahead and start with, even for this initial task, even though we had limited time, we wanted to pick a couple of areas that within LSI that are very cross-cutting, that have a lot of integration, a lot of tentacles. And so we did pick ISRU and surface power for those reasons. So they've kind of been diving down on specific tasks within those two domains. So let's talk a little bit more about the consortium itself. The real idea of this consortium, if I had to sum it up, is we really want a forum where industry and academia and government can come together, where NASA, for example, can say, okay, here are those key figures of merits, those key capability needs, and really articulate what we're looking for. And then hear back from industry and academia where the value proposition is for them. So if we're going to go into these models where we're truly working together, and that chart I started with in terms of meeting NASA objectives as well as that global space economy, then it takes a lot of discussion and dialogue on where the value proposition is from day one, right? And how we, if we're going to do public-private partnerships, how we establish those in ways that are meaningful for both of us, all of us, I should say. The good news there, like I said, is we all need power. We all need ISRU, we all need comm, we all need nav, mobility. So there's a lot of fertile ground to sow, and that's where we want to start. So these are just kind of some of the key tenets, and I wanted to talk in terms of timeline. So from June through October, and still continuing a little bit into November, actually, APL has been doing what I'll call kind of informal interviews across industry and academia and other government agencies, and within NASA, they've been talking to these key stakeholders and potential participants to say what we're trying to do, and then to listen, to hear and get feedback on what would be meaningful for that community. November, and they'll be submitting these recommendations. We're working together on our package, and then in December, like I said, we go back to the Acquisition Strategy Council with our recommendation. We do actually, and this is kind of breaking news, and I'm going to cheat a little bit, but we do, there'll be formal invites coming out, but we do have a kickoff for the consortium scheduled for the end of January at APL. And so we can talk that more as I hopefully get to talk to you more individually throughout. All right, so I'm going to stop there and pause for questions.
Jerome Kadar, JPL. So I want to touch on regarding prospecting and following the picture of the geophones. In the engagement with industry, is there also engagement on the prospecting side? Landing on the moon and prospecting could be a huge difference if you have even a local survey saying, don't drill over there, drill over here, could save you 5 days on the surface. Is there an active engagement with prospecting industry, the representative Society of Exploration Geophysicists?
So I actually believe, I see our SMD brethren back there. So we're actually all working together, but SMD is leading quite a few studies, and there are existing institutes where they're having those discussions as well. I see Ben and Steve back there. So I think I won't steal their thunder, but I'm sure they'll be talking that more this afternoon.
Mark Robinson, Arizona State University. The question is somewhat similar, so maybe you'll give the same answer and put it off to this afternoon, which is fine. But you did have on your slide up there prospecting, and it showed up once or twice, but there was really no meat to the matter in terms of how we're going to do that, because you need to determine the ore extent and the grade and tonnage of what your ore body is before you even design your ISU instrumentation. And how are you going to get that ore from where it lives or hangs out to the ISRU widget? And those are big, big steps that requires multiple missions, money, and time. Yep. And so your timeline does not seem realistic.
And that's because this doesn't show all the CLIPS missions, which Steve or somebody's going to be talking later today, which will go into a lot more detail there. This was specifically for the STMD, for the technology development, but we are working closely together. We have a federated team and meet on a regular basis on how we're actually going to utilize the CLIPS missions. There are multiple payloads that we're utilizing the data from to incorporate into our technology development as well. So I know it's not all on that one chart,
so we'll
but you'll hear a lot more. Yeah, you'll hear a lot more in the clips.
Right.
And that really is the first thing out of the gate, and why I said we're tied at the hip, because that is such foundational data for all of us. Where SMD may use that obviously to inform their science requirements and science planning, technology will use that same exact data to inform our technology development and some of that kind of if-then mission planning with HEO and the architecture. So I think the early days are going to be extremely exciting. That initial data will be priceless.
Am I allowed?
Yeah, go ahead.
Clive Neal, Notre Dame.
Hi, Clive.
Very intrigued to hear about the power partnership feeding into ISRU. At the July workshop for Lunar ISRU, power came up time and time again.
Sure.
And we may be underestimating what we need in order to conduct that. So I'm hoping that would be part of this study that APL is undertaking to realistically look at what we need, not only to extract, but to refine, store, transport these products, because that's going to feed into, is it economic?
That's right.
So I'm
for
hoping
all of us, yes.
Everything is going to be hopefully coming to light next year, according to your timeline.
Absolutely. And so that's why I like to use the power example, because it's something we all need and something that I think we could all say is somewhat underestimated in terms of how much we need. But I think the key, like I talked about earlier, was determining early on and how we phase in terms of what our key power requirements are as we phase through the missions. I mean, we'll have to be scaling up. I think we're going to have a multi-pronged approach in terms of technology development. And I think that's why it's so key that we're starting now with some of the hard discussions and asking the tough questions. I think we are really starting to develop an excellent plan and implementing that, which can't talk in tons of detail yet until our budget comes out, but I'm very excited, and there's been a lot of discussion in terms of power. I think the first step, obviously, is understanding our basic requirements, at least for these scaled systems, and that's why I said it's so important to understand when we say a given capability at a relevant scale, how are we phasing that scale, and are we bringing along our infrastructure? Because the same thing with excavation, by the way, and the same thing with comm and nav and mobility. And so we're having those discussions now.
That's great. Thank you.
Yeah, thank you. Thanks, everyone.